Hello everyone, and my name is Liu Jingxuan from Hohai University, and my research work is about harvesting spatiotemporal correlation from sky image sequence to improve ultra-short-term solar irradiance focusing. My research works begin with the introduction part. Currently, with the profound integration of renewable energy, the application of renewable energy in the construction of smart grid is becoming increasingly crucial in mitigating global climate change and attaining sustainable development goals. However, because solar irradiance is a critical component affecting PV power, its intermittence and uncertainty can cause variations in PV power output, which significantly affects the stable control of power grids and limits its large-scale deployment. Therefore, obtaining solar irradiance focusing with high accuracy is of great significance. It can not only reduce backup expenses but also promote better power quality. Therefore, our research work is motivated by that the majority of factors that affect solar shading was spatiotemporal dependent. However, few studies had applied local feature extraction and emergent methods to reconstruct vital spatiotemporal information, and therefore applying objection detection techniques is feasible to boost the extraction efficiency of dynamic features. And our contributions can be illustrated as follows. The first, a novel spatiotemporal feature extraction method based on the improved cuboid descriptor was proposed for ultra-short-term solar irradiance focusing. The second, with spatial invariance maintenance, spatial parameter pooling enables size-varying feature maps recognized for the decoder, which improve the robustness for samples with substantial information variations. The third, an end-to-end prediction model with ground-based sky images, previous solar irradiance, and, for example, previous meteorological data as input was proposed. And secondly, we'll detailedly introduce our methodologies. The problem is how to harvest spatiotemporal information. We have done this concern by propose a novel spatiotemporal descriptor, namely cuboid, which was improved for ultra-short-term solar irradiance focusing. The spatiotemporal descriptor includes 3 stages. The first is detect interest point from sky image sequence. The second, considering that the selected candidates has a lot of reductancy, so we use 3D soft non-maximum suppression algorithm to filter out unnecessary candidates. And the third part is visual transform. We use farm-back optical flow calculation to extract dynamic features from raw sky image sequence. The first stage, obviously, is interest point detection. It also includes 3 sub-modules. First, we applied Gaussian filter and 2D Gaussian filters to obtain response function. The third, we select a regional maximum as potential candidates. The third, we considered appropriate radiance and temporal scale to form potential cuboid descriptor. The second part is 3D soft normalized MNS. It is motivated by that the spatiotemporal feature represented by neighbored interest point tends to exhibit high similarity, which results in computing redundancy. So, convention hard and NMS methods hardly considered the mutual influence among candidate points. Therefore, simply perform threshold can cause future elimination. So, in our case study, we performed the 3D soft non-maximum suppression, and a visualized example is presented in the right bottom part of the PowerPoint. The third is visual transformer. We adopt front-back optical flow calculation to make the feature maps more learnable for the CNN networks. We modeled a single sky images by using a polyquadratic function, and continuous consistency is used for practical use, and also a likelihood function considered neighborhood W of X is established as possible. The third is experimental results. We performed our proposed method in the dataset of NREL, and all the sky images and solar measurement is within 10 minutes scales, and we also adopt a fisheye image distortion correction method for data pre-processing. This part introduced the model configuration results. We have carefully and detailedly investigated the effect of image length and its resolutions on the focus accuracy. Also, the vital parameter within 3D soft non-maximum suppression was also investigated. Therefore, based on the optical hyperparameter searching results, an apparent improvement can be obtained where the normalized root mean square error is improved by 4.52% compared with suboptimal results. Also, the general performance of GHI focusing is presented as follows. In this figure, we have presented GHI focusing results ranging from 10 minutes ahead to 60 minutes ahead. Referring to the figures, compared with baseline models, the proposed model effectively fits the GHI variations and effectively focus the attribute fluctuations, which indicates that it has highest accuracy and robustness in various weather conditions and multiple prediction horizons. And the visualized example in our case study also shows the high performance of our proposed method, in which our proposed method did not degrade apparently as focusing horizon extends. And lastly, the performance of the proposed method on ramp event focusing is also presented. Firstly, we define a ramp event of GHI, and also we characterized all the ramp events to the 4 classes, and namely significant ramp up, insignificant ramp up, and insignificant ramp down, and significant ramp down. We also designed comprehensive performance indicators to show the performance of the proposed and the baseline models. So referring to the experimental results, our proposed methods successfully focus the attribute fluctuations within GHI series, and referring to all the RAM event categories, our proposed method has ensured the highest accuracy compared with the suboptimal model as served, which means speeded up robust feature extraction method. The last part is conclusion. In this study, we propose a novel method because few studies have focused on effectively harvest vital spatiotemporal information from sky image sequence. Thus, this study comprehensively investigated sky image-based ultra-short-term solar irradiance focusing by proposing a sparse spatiotemporal descriptor, namely cuboid, and the spatial parameter pooling is also followed to refine the extracted dynamic features. And referring to the experimental results, the case study has effectively shown that the proposed method achieved NRS as 4.80% and the F1 score is 1.59 in 10 minutes ahead GHI focusing. Compared with the suboptimal method as served, the proposed method obtained 5.51% reduction on normalized RMS and 10.1% improvement on F1 score. And also, as for the future works, developing efficient pixel-sensitive focusing models based on ground-based sky images can be a focal point in the future. And furthermore, the research on refining the description of dynamic cloud motion also need further research. That's all of my speech. Thanks for listening, and if you have any problem, just contact me at my email. Thanks for your listening again.